Looks like we can start. Welcome back, folks. We're about to finish off week 4, so we're 25% done with the semester after class is over today. It's going by fast or slow, depending on your point of view. I have a whole bunch of announcements I wanted to get through, but some of these things are just kind of just repeat information. It's all important though, so going down the line of all this text, your quiz 2 is due today, and quiz 3 is now posted. I've been mentioning things about scanning your quiz and giving you feedback. So with your quiz two handed in, watch your ISU email address on Friday when I begin grading. I'm going to scan your quiz and send your feedback back to you. That way you have some important information feedback to help you out with the first exam. And quiz 3 is also important. The due date is officially September 25th, but if you decide to do this early, it's great practice for exam 1. And if you want your feedback right away, you can scan it, take a cell phone picture of your graded work or your completed solution, send it to my ISU email address. You can find it on the syllabus. And I'll make every effort to grade this and get it back to you before Monday's exam. If you get it to me on Friday, Saturday, Sunday, I definitely will be able to give you their feedback. If we're working on a Monday, it's going to be hit or miss. I'll try my best, but I will run out of time quickly around 3 o'clock on a Monday. So the quizzes, again, they're meant to give you a really good idea of problems you should be really fluent with, ready to go on, good preparation for exams. I try not to waste your time on the quizzes, so that's why I'm trying to get your feedback returned to you ahead of the exam as well. So exam 1 is next Monday. Like we mentioned, it's from chapter 1 and sections 2.1 through 2.5. So I guess chapter 1, chapter 2 is a better way to say that. One big resource on this exam is it is open notes. Some people have taken this exam without notes. They just felt like they didn't need it. And I mean, that's a judgment call on your part. But if it was me, just the action of writing down the notes is massive study and preparation for the exam itself. Information has a way of just solidifying once you write it down. Even if you've read things 10 times, writing it down once is really powerful. So my advice is write down your notes early. Some people have already gotten that done. That's awesome. And if you have it done early, use that notes as a resource for studying because you want to know where everything is. You want to be familiar with every little nook and cranny you stuck in information. Sometimes having this ample real estate for notes is a hindrance because if you write a lot of information there, I've seen people just kind of examining their notes in great detail using a lot of time, and that's probably not helping you at that point. So use those notes to actually study to help you solve your quizzes, your quiz 3, for example, and it will be a great assist as well. That's pretty much all the guidance I had about getting prepared for the first exam. Sorry, we're not there yet on the first exam. The other guidance is it's pretty much the things we've been doing all along. We've mentioned before, my lab statistics, it doesn't transfer on paper that well. It's just where you kind of connect the dots from what you did in the reading, what you actually read, and what we did in class. It's a way to just get some really quick practice in. The exam questions are going to be more similar to things you see on quizzes, the things you see on either one of these 2 sample exams. And this one's been revised. Thanks for mentioning that issue on quantitative data being either continuous or discrete. I struck that out from the problems and I revised the actual solutions. The revisions are in red now for those problems. But I think that's my full spiel of announcements. Hey, that only took about 4 minutes. But any questions about the exam whatsoever? Yeah. Yeah, that's kind of confusing. So the way version 2 goes is pretty much what all this is kind of just a do-over. This one is example 3 from the chapter 1 notes. So even though there's no solutions here, you can go all the way up to chapter 1 notes right here. And notice this one starts at example 1. So this is also version 2, my kind of way of saying these are the big questions that really work as exam questions. Examples 3 and 4. Go to the Canvas webpage, the chapter 1 notes we solved, and you can just scroll down to the examples 3 and 4. Sometimes people have discovered stuff is missing. Maybe I forgot to upload something. let me know right away. It's on my thumb drive and I'll fix it right away. Does that make sense for the version 2? Awesome. We're going to be doing this pretty much for every exam. In fact, when we go to the final exam down here, I'll be posting the same kind of resources, a version 1, a version 2. At that point, it's a cumulative exam, so it's just going to be all the problems all at once in one little spot, pretty much. Other questions about the exam so far? Awesome. It's not going to be too bad. So if you've been keeping up with the course, doing the quizzes, doing the MyLab statistics, it's going to feel like, well, it's just more of a formality. I can't ask the same question again. I can ask a question just like it, slightly different context, different things on the columns, and same kind of questions. Yeah, go ahead. It's pretty much going to be, yeah, the heavy emphasis is definitely chapter 2 on this exam. It only goes up to section 2.5 that we finished on Monday. So anything new that we do today, this is all going to go on to our exam 2 material. And the reason for that is I feel like when you learn new material on a Thursday, then you go to take an exam on a Monday, that's really not how learning works. It takes time to practice with those problems, get feedback on how you're doing from graded assignments and quizzes and stuff. And so that's why I kind of make a cutoff to something we finalized on Monday, maybe is probably fair game, but Wednesday, Thursday is a little too early for the exam. It will have stuff from chapter 1, but see the either version and you'll have a good idea of what kind of questions are going to come up. But we spent most of our time in chapter 2, so it's going to be more weighted in those kind of questions. Other questions at the moment? Okay, I mean, that kind of misspoke. Aside from other questions, this is the point in the course where pretty much we're open to just take any review question you might have on the exam. Any review problems that folks want to discuss, look over, either from either one of these sections, old examples, old quizzes, and so on. Or maybe some weird problems you saw in MyLab statistics. Those could be great review questions as well. Okay, no worries if we don't have review questions. Honestly, it's hard to know what to ask sometimes because it's all kind of there. At any point as we start our class lecture notes today, we're going back to chapter 3. If you decide, yeah, I do have a question, don't hesitate to interject. Learning is sometimes kind of a chaotic process. I'm okay with switching gears. So we're nearly done with chapter 3. I pushed the due date of this one back by a day because I didn't complete it on Wednesday like I thought I might. And this chapter 4 is also ready to go for us. The due date on this one is already in October, so we'll finish this chapter 4 when we come back on Wednesday's class. Also, if you're studying for the exam, I mentioned at the start of the course that I usually don't email too much on Saturday and Sunday, but this kind of weekend is special, right? It's a weekend as we go into another exam. So if you have burning questions about exam 1 review problems that you're working on, I am checking my email a little bit more often, and so I will be able to get back to you. So don't hesitate to write, even on the weekend. But here's where we left off. Chapter 3, we're looking at a contingency table, which is another way said, a two-way table, handling 2 categorical variables. We did a lot of different kind of stuff on this. First thing we did was decide what are the variables themselves, what are the individuals. We looked at looking at a single variable at a time. That's the marginal distributions. So the hepatitis versus tattoos, we were looking at the totals either on the rows or the columns. We looked at conditional distributions where we restrict our attention to just one part of the table. And then finally, we did some various probability type questions. So after we did all this kind of work, it kind of culminated down into looking into graphics based off this kind of information. So this is the same original table. If we want to make a graphical display, we went for percents, which was a good call, right? Because these totals are just way off. If we were to make a bar chart that was based off the frequency, well, this row would be hardly visible at all, right? It'd be so tiny relative to the one that has size 513 in length. So we really needed to convert this to percentages to really see the differences between how the variable hepatitis changes, having hepatitis C or not, and having a tattoo or not changes. And we also complained about a lot of problems with this table. The graphics were put together, just basically slapped together. It shouldn't have gone up to 120. These are percentages. And full disclosure, I made these graphics in Excel. Probably should have paid more attention to that. And even worse, the message just seems to be missed here when the good outcome, no hepatitis C, is in a strong color, making it look like something bad. So that was really odd as well. But this was one way to visualize the table using row percentages. And if we look through the categories here, it seems like the percentages for hepatitis C really do change whether you had no tattoo, a tattoo elsewhere, or a tattoo done in a parlor. These percentages for no hepatitis C changed a lot, and so did hepatitis C then. And that's just one way to look at the data. Another way to look at the data would have been this way. Here, I didn't make us do the column percentages. I feel like people find that to be pretty tedious doing it just once as row percentages. Or it looks like I didn't do the percentages here at all. Wait a minute. Yes, we did. These are all percentages now. I just didn't put the percent symbol. Essentially, what I did to create this table was went back to this original one, took 47, divided into 17, h divided by 47, 22 divided by 47. And that's how these percentages emerge. So looking at it from this point of view, here's the same data. And now hepatitis C, well, that doesn't have a color any longer. So maybe this is the better chart. The only thing that has colors here is tattoo, parlor, tattoo elsewhere, and none. And now the colors don't really have that same kind of impact like they might have for comparing hepatitis C against not having hepatitis C. So it says, here's the contingency table again. Describe what you see in these displays. I'm not sure why I pluralized this one. I think this one makes more sense just saying this display, just focusing on one at a time. And this is kind of a tough question. Even though this is not an exam 2 question, something like this could come up on exam 1 where it's just one categorical variable. And so the bar chart isn't segmented like this. So this is kind of good practice for exam 1 all on its own. Hard to come up with what to say, but we have to say something. And you know what? Let's add one more thing here that I should have said. Describe what you see in this display. This is throwing me off. This is going to be something commonly asked for on the exam using the context. Let's emphasize that change. That is a revision after the fact. The notes were worked on. But that's something that's going to be expected a lot on the actual exam. So let's do it here as well. We have to recall the context was, well, it's kind of looking at us, whether people had tattoos or not, where they got them, and whether they had hepatitis C or not. Any volunteers for something to say about the display as we see it? For the display below of the two-way table, any information that you would say, just any information that pulls at you right away for describing it? It's kind of hard to know where to start, right? That's the tough thing about these.
The
Yeah,
higher percentage of people with Hep C have tattoos from a parlor.
let's take a look at that. Tattoos from a parlor with hepatitis C. Yeah, so we have a lot of people having, let me look at this graph one more time. So tattoo at a parlor is blue. no tattoo is green. Yeah, for some reason that just kind of threw me off. I was expecting something different, but yeah, if we look at tattoo at a parlor, that's this blue, really minimal here for no hepatitis C, and greater area here on hepatitis C. Is that what you were saying about that information? Let's put that in words. So for those individuals that have, I'll just write hep for hepatitis C, a greater proportion or a larger percent have tattoos in a parlor. Let me think about that wording now that I wrote it down. Does this make sense? Let's take a look at this. For those individuals that have hepatitis C, so I'm looking at just this category, a larger percent have tattoos in a parlor. That doesn't seem quite right, does it? The larger percent have no tattoos. The sentence doesn't quite flow by the way I wanted to write it out. Does that make sense? So even though we're saying something about the display, if this was my final answer on this, I think I missed the essence of what you were saying. It made sense when you said it first, but the way I wrote it down, it doesn't seem to be true at all. I could potentially lose points on this one. Let's strike it through because it's good to know what doesn't fly just as well as what is expected. So what's a better way to say that information? So among those individuals who have tattoos, so now we're thinking of just tattoos, which is this whole segment here, and this whole segment here, both the blue color and the orange color. It's just separated out by where you got the tattoos. Among those individuals that have tattoos, a greater percentage have hepatitis C. Let's test out this statement. This one I struck through. This could be a loss of some points. It's not like you lost the whole question. You're talking about the context, and that's part of the partial credit on this problem. But it said among those individuals that have hepatitis C, so we're stuck there, larger percent have tattoos in a parlor. That was this small segment. The larger percent is no tattoos in that category. So it didn't fly at all. It seems to be contradictory. This one's now saying among those who have tattoos in the first place. So we're thinking this category and this category here, both of them put together, greater percentage have hepatitis C. So yeah, if we look at these versus these, way more hepatitis C in this situation, and small percentage for no hepatitis C. I think that's the correct statement. Would you all agree with that? A better way to say it? It's a little bit tricky again because I was trying to get there, but it's the order I said it that was wrong. I mentioned hepatitis C first, then it's a contradictory statement. I should have said individuals who have tattoos first, then refer to the condition hepatitis C. Many other things you might have said here. Any volunteers for anything else you want to throw in? As an exam question, this would hit the mark because it didn't say, give me 5 different points, different piece of information. It just wants something that just seems striking to you looking at the data, and this did it. But any volunteers for anything you'd want to add at the moment? I think that's a good one to throw in as well. Let me know if I lose the wording on that. Let's say additionally, among those, and I believe you said who have no tattoos, a greater percentage have no hepatitis C. Is that about what you were saying? Awesome. And yeah, if we look at the none category, so no tattoos, we're looking into this and this. So we're only restricting our attention to this part of the segmented bar chart. And yeah, the percentage is greater among no hepatitis C category. So yeah, that really is striking here. There's just a huge difference from here to here. Maybe that's even the bigger difference. Well, from here to here, that's pretty pronounced too as well, how those categories shrunk way down at the same time. But that's pretty striking as well, going from here to here. So those are great things you could say for this kind of thing. Anything that pops out to you that seems important is worth mentioning right away. And now that we have this, these are the kinds of things that people would be looking at when they did the study. And one question that they would want to see if they could answer is not about cause and effect, but it might be about the independence of that tattoo variable versus the hepatitis C variable. We want to know, are they independent of one another, or are they dependent with on one another? We need a good definition for this. So here is the textbook statistic definition. Variables, so think tattoos versus hepatitis C, those are our two variables, can be associated in many ways to different degrees. And in a contingency table, this is what we're looking at now as a graph. In a contingency table, when the distribution of one variable is the same for all categories of another, the variables are independent. When the variables are independent, there's no association or relationship between these variables. And that's what the study was looking for. It was looking for a relationship, not a cause and effect one, but just how the variables interact with each other. So looking at the table, here's the contingency table. The percentages are quite a bit different. Looking at it from this point of view, this is the same information as a segmented bar chart. With the categories changing this much, this is not independent. So when it asks us, do these data indicate having hepatitis C is related to they have tattoos? In other words, are they independent? We would say, yes, there is a relationship. They are not independent. If the variables were independent, then the size of this segment would be the same over here. It would just go from here to here. The size of this segment would be the same from here to here. And the size of this segment would be the same from here up to here. So if we had essentially the same chart roughly over here as well, maybe not exactly because data has random effects going on, but if it's really close, then they start to look like they're independent. That having hepatitis C is independent of any one of these three conditions on the tattoo variable. But that's not the reality. This condition here in blue shrunk way, way down. It didn't stay the same size. And the same for the other categories. And so that's why there really is some relationship going on. That's pretty much what you were describing when you wrote out these words here. That's the relationship that we're noticing. We're not saying that it's a causal one, but it's just something that's being shown in the data. We can add here to our conclusion. These data are not independent because the size of the categories changes significantly from hepatitis C, referring to this first column, and no hepatitis C, referring to the second column over here. I put it in brackets because we weren't really being asked to explain ourselves on this one. I didn't say explain on the instructions. And independence versus dependence is one of those big things in statistics where this may not come back as a good exam question, maybe not part K. That's just another way for us to think about everything we did in this problem and what they were trying to do in this study. Ideas of independence and dependence will come back later on as we get through other topics in probability. But that's a conclusion of dealing with two categorical variables so far. There's a lot going on in chapter 3. We're only doing sections 3.1, 3.2. If you read a little bit further, then you'll see how to handle 3 categorical variables, another interesting information. And further on in this textbook is statistical procedures for categorical variables, but it goes kind of beyond the scope of this course. So the main purpose of this whole chapter is just seeing what multiple variables are going to look like in these data sets and how to handle them, how to think about them. So on exam 2, it'll be similar questions to these, but maybe not quite part K. Any last questions at all, folks, with the conclusion here of the chapter 3 notes? Okay, next we're going to go into chapter 4. I don't expect we're going to finish our chapter 4 today, so it's something we'll complete on Wednesday when we come back after the exam. You know, the good news about chapter 4 is chapter 3 was handling 2 categorical variables. Chapter 4 is back to a quantitative variable, and then scenarios with a quantitative variable and a categorical variable together. A lot of the work we're doing in chapter 4 is reviewing chapter 1 concepts, or excuse me, exam 1 concepts already, even though the full chapter 4 is going to come back on exam 2. So we'll do a little bit of review work just delving into this next section. Let me make sure this is saved. And let's jump into that next section then. Well, it's a next chapter. Same issue on chapter 4 as well as chapter 3. We're not covering the entirety of chapter 4. See sections 4.1, 4.2 in the reading. That's going to be our major focus. Here's how it goes. Oh, and I did say one other thing. Example 4.1 can be safely skipped. You might as well read it. There's no harm done. But it's creating a certain kind of display called a stem and leaf plot. Some people might have done this before if you've taken some of these concepts before. Nothing wrong with stem and leaf plot. It's a great way to make something that looks like a histogram drawn by hand. But we're focusing more on just the computer graphics in this course. So that's why if you skip section example 4.1, there'd be no harm done. So these are the major topics we'll be covering in chapter 4. We're first going to take a look into the 5-number summary, but look what it involves. This is exam 1 content. Lower quartile, that's quartile 1, the median and the upper quartile. Let's write this in our notes with the way we wrote it in the prior section. Lower quartile is referring to quartile 1. Median is referring to n. Upper quartile is referring to quartile 3. Double checking, it should go 1 and 3. I think I remember getting that backwards in the notes. I did revise the Blink lecture notes on that typo. So what we'll be doing on this example data, this is a redo of some similar data we've had before on the radioactive Pacific bluefin tuna. We'll be calculating the 5-number summary on this data set. And the next thing we'll do is use a so-called 1.5 IQR rule of thumb to see if there are any outliers in this data set. So this is the rule of thumb for outliers that we've been promising all along. Rule of thumb is down here below, and just based off quartiles and the interquartile range. So first, let's give this data just another refresher on what the context was. We're using radioactive cesium as a measurement of radioactivity because it's specifically a waste product of nuclear reactors. And they caught a random sample of 16 Pacific bluefin tuna. So sample size is 16 here. Off the coast of California, 4 months after the nuclear meltdown in Japan of 2011. So here's the data. I'm not sure if we had a histogram the first time we looked at that data. So here's the histogram as well for these data. It's kind of an odd looking one. This looks like it's bimodal data. We have a main peak from 6 to 8 becquerels per kilogram and another between 10 and 12. So if we did a really fast summarize of the shape, this is an exam 1 review question in its own right. For the shape, we would call this bimodal. I think bimodal is a good designation. Some people might find this debatable because there is only one rectangle separation between the two peaks. But I think most often people would default by saying this is bimodal. There is strong concentrations on those two ends. It's bimodal, but as far as symmetry goes, they folded along that line. What would you say? Is this symmetric or would you say it's skewed?
Roughly.
Some for roughly symmetric? I wouldn't disagree with that. I mean, looking at this, where would we fold? If we fold from here to here, this would end up in that spot. This would end up here. This would end up here. They're not quite overlapping, but what if we folded from about here instead? We fold from that position. This goes to here. This goes to there. It's just a little bit off on that one. And there's just one extra rectangle off to the left. I would agree with rough symmetry on this. Some of the folks who might felt like it was skewed, I would say a slight skewed left is a good answer to this as well. This is probably not going to make a good exam question because it's kind of debatable. I could see it both ways. So let's say this is bimodal, roughly symmetric, with a left skew. And visually, if I looked at this, I would say no outliers. But that's just us doing a visual assessment. If there really is outliers, a good rule of thumb ought to spot it. And that's one thing that we're going to do with this data. First thing we'll do is compute the 5-number summary. And this is the list of things we'd have to calculate. Before we launch into that, any questions on this review portion here, just determining the shape? Okay, so this part right here, definitely it's exam 1 content. Knowing how to use the calculator is part of the objective of the course, so I can't help you with using the calculator. I can help you if something is just not working right in your calculator. Like, for example, if something is wrong with the data entry window, I can help out with those kind of things. So let's treat this as an honest exam 1 review question in its own right. Very first key you hit is the stat key. And in this menu here, hit enter right away. I often go up arrow, hit the clear button, and enter to wipe out the prior data set. And now I'll get quiet at this point as I type in the data. I'll go row-wise. I think I messed up. Oh. Let me double check my data. The way I'm a little concerned is it said there's 16 pieces of data. And I am looking at 16 pieces of data, and I have a blank for my 16th piece of data. So This might happen to you in an exam setting. Don't panic, go to the top of the list. Pretend you're like a forensic accountant and just check them again. I missed an 8. That's what I did. There's too many 8s there. I think it threw me off. I need to go to the bottom of the list because if I type in 8 anywhere, I'm going to overwrite and I have to retype everything out. It's okay to put them in a different order, so I'm just going to go down to the bottom of the list, put an 8 there, and I should be good. Anyone need any additional time on the data entry? Okay, data entry is a pretty not fun thing, but it's part of statistics. It's part of the experience, and messing up will happen eventually. We're going to see how close we all got. So we kind of went through that a little bit fast. Once you're satisfied with your data, not a bad idea to double check like we just did. Well, I had to. Hit your stat button once again. Now you need to use the right arrow here. Navigate to the point where calc is highlighted for calculate. And if everything is set up correctly, just hit the enter button multiple times and it will output the information you need. So we've got it. So let's double check our numbers. I'm kind of suspicious about mine. I came out with a sample mean 10.11875. Does that look right to folks? Awesome. So usually if even 2 people or 3 people are getting the same piece of data, it's overwhelming numerical evidence that we got it in right already. Well, we want the 5-number summary. Scroll down to this point and put them in. If you go down arrow, all the way to the bottom, this is the 5-number summary, and it even tells you your sample size as well. So we just need a copy of that information. On the exam itself, you might need quartile 1, quartile 3, the median, interquartile range. You might have to give the X bar value, which our book writes as a Y bar, and the sample standard deviation S. It's always the bigger between these two on the bottom here. But for our notes now, we're grabbing these values. So I'll write in min equals 4.6. I'll write in the unit, becquerel per kilogram, just as a reminder, that's what the context is. I'll only write it down once though, because that's a hefty unit to put down. It's implied everything has the same unit. Quartile 1 is 8. The median or 50th percentile is 10.5. Quartile 3 is 11.8. And max is 15.6. That looks about right. This data is sorted. Here's the min 4.6, max is 15.6. The median is the 15th percentile, 10.5, which would be between 10.4 and 10.6. It's the number that cuts the data set literally in half, an upper half and a lower half. So everything looks about right here. Now we're going to determine if what we said here, no outliers, works with this rule of thumb. This rule of thumb identifies an outlier in this data set. I think a lot of people would agree maybe it's not a very good rule of thumb because it really visually doesn't seem to have an outlier. If this rectangle right here was instead moved 1 position to the left, here, then it's a maybe. It might flag that as an outlier. It might not. At that point, it is just a rule of thumb. So let's give this a try. What we need is the 5-number summary. We don't use the min max directly, but it's good numbers to have available as we go to do this. Really, the minimum and the maximum are going to be useful for something else later on called the box plot. So here's how it goes. First thing we want is, if it's a 1.5 IQ or rule of thumb, we need to calculate the interquartile range. Let's in fact start right there. Step 1 is to get the interquartile range. So a reminder on interquartile range is that it's quartile 3 minus quartile 1. So we'll take the Q3 value, subtract the Q1 value. This becomes 11.8 minus 8. So we get a 3.8 altogether. Well, it's 3.8 becquerels per kilogram. Doesn't hurt to write in that unit. You don't have to, but if we have to say anything about any display we might build, just writing down the unit is a good way to keep the context in your head as you go. So now, after step one's done, here's what step two looks like. Essentially, what these are cutoffs. It says an observation will be flagged as an outlier by this rule of thumb if that observation is larger than quartile 3 plus 1.5 IQR or smaller than quartile 1 minus 1.5 times the IQR. And to make head or tails of this, recall what the interquartile range even is. It's the distance from quartile 1 to quartile 3, which means it's the distance that contains the central 50% of all of our data. So if anything is further away from the 75th percentile by 1.5 times the distance of the central part of the data, we say that's pretty far away. It's an outlier in that case. So it's just one way to give a cutoff of what's far and now unusual becoming an outlier. Now we have to calculate it. So the one thing to keep it together in the notes is you can really get this formula going good by recalling if you're doing the greater than part, you're using quartile 3 and you're using a plus. For doing the less than part, then you're using quartile 1 and a minus. And it kind of makes sense in a way. 3 for plus, 1 for minus. The rest of the formula is the same. 1.5, the IQR. So let's go in order on this one. For the upper end, I'm writing down upper end because I'm looking if there's any outliers literally on the upper end of the histogram here. We don't see any, so we'll be surprised if we flag anything as it. The formula is quartile 3 plus 1.5 times IQR. So we make a substitution next. This feels like kind of an algebra problem at this point. There's two things to substitute in this formula. First quartile 3, 11.8. Then go plus 1.5, 3.8. That's our interquartile range. And then we just jam all this into the calculator at this point. Does that make sense to folks on where all these values went? Okay, again, it's kind of like an algebra problem because we make two substitutions. So follow the color coding, drop them in that order, and it'll be all set. Some people really respond to this kind of color coding, especially when the formulas get more convoluted. And if you like this kind of stuff, there's no harm in actually bringing color-coded pens to class, except that it could get expensive for nice color-coded pens. That's the downside. But if you're getting into the habit of doing that, maybe digitally, you can bring this to an exam setting, maybe color-coded highlighters, and that'd be terrific, I'd say. So in the calculator, go 11.8 plus, I'm just typing this in verbatim, 1.5. You can use the parentheses if you'd like. Using the time symbol over here is just a little bit faster. 3.8. And we get a value of 17.5 becquerels per kilogram. So let's remind ourselves on how this works. Any observation larger than this is an outlier by this rule of thumb. But if we look at our max value, 15.6, everything is below 17.5. If we look at the histogram suggests we only go up to 16. In fact, the value is 15.6 in the sorted data set. So we can tell already, just comparing against the maximum value, that there are no outliers on the upper end. And that means we're halfway done. Just because there's no outliers on the upper end doesn't mean we've ruled out outliers. You have to check the lower end by using the second formula down below here. But that's our conclusion on step 2. Does that make sense to folks so far?
Do you wanna see that? On an exam?
That statement there?
No, the work.
Oh, for as far as the work goes, I would say if you put this on paper, you're doing just fine and giving a number. Yeah, that'd be okay. If you just gave a number 17.5, no, honestly, I think I would be okay with that on the exam. I just assume you would know the formula really well. The more you actually put down on an exam, the more partial credit you could get. So the only thing that could be a worry is suppose I just messed it up in the calculator. I've messed up numbers before already and got 13.8. And if this is an exam 2 problem, if all I have is the number 13.8, we could lose all the credit on step 2. But if I saw this stuff, I'll know you just made a calculator error. And I treat this as massive, massive partial credit on real exam settings. This is a comment I actually say a lot. We just haven't used formulas a lot yet for exam 2. If this is on your exam 2 problem, I know what was supposed to go in the calculator. I'll assume you're like me and your thumb was too wide and you hit a wrong button or something. And if step 2 is 5 points, I would give you 4.5 points for having it correct on paper, even if the number is way, way off. If all I have is the number, though, I lose basis for that partial credit. So I'd say if you're on an exam setting and you just know you've done this a million times, you know 17.5 is right, I'd accept it for full credit. But if you've got the time, write this stuff down because stuff happens with putting things in that calculator. This is like the insurance of the problem, basically. Other questions at the moment? Okay, I actually repeat that a lot, like I'm repeating the same comment a lot. We'll use a lot of formulas when we're getting further into the actual inferential statistics. Formulas go kind of like this: y bar plus or minus a value s divided by the square root of n times some other number z star. We have to plug in a whole bunch of information here into this random formula, which will come back later. But if I see how you plugged it in on paper on the exam setting, you get massive partial credit, even if you make a mix up on the calculator. I'll understand that you know the concept, you know how to evaluate the formula, and that's where a lot of credit can come in. Well, let's try out step 3. Thanks for asking about that. Other questions at the moment? Okay, kind of running out of space for step 3, so let's drop this on the next page. I want the formula to be visible as well. I mean, we're still learning it. I said we did want that border after all as well. So here's our step 3. It's practically the same song and dance, except we change the formula a little bit and we look for the outliers on the opposite end. So we're now on lower end. This time following the formula below, but also take a look at how it changes. If you memorize one formula, it's a small step to memorize the other one. Even though these exams are open notes, the more you memorize the formula, the easier it is to use in the first place. From Q3, you go to Q1. From the plus here, you change it to minus. And that's the whole change here. Just copy the rest of your formula, 1.5 times IQR. Now, let me look up. It should be 8, but usually you'd be looking up here. Quartile 1 is 8, so I'll substitute that in to this position. This is equal to 8 minus 1.5 times 3.8. Plug that back into the calculator. Go 8 minus 1.5 times 3.8, and we've got a 2.3. 2.3 becquerels per kilogram. So the reminder again, like before, We now need to look at our data. We might be looking at the minimum value. We might be looking at the original observations, but an observation, a data value, in other words, smaller than this is an outlier by this rule of thumb. So let's check. 2.3 becquerels per kilogram. Sorry for scrolling up and down a lot. Well, the minimum is 4.6. We see it on the histogram. We don't go to 2.3. That's data out here. We had data out here. That would have been an outlier for sure. The minimum being 4.6, everything larger says nothing is smaller than 2.3 becquerels per kilogram. All of our data is within 1.5 times IQR of quartile 3 and quartile 1. So we just need a small conclusion here. No outliers. You could just say no outliers at this point because now there's just no outliers. But more specifically, no outliers on the lower end. So that's how the rule of thumb goes. Maybe it didn't feel too interesting because we didn't find any outliers, but the next example will. So we'll take a look at this at a second time. Well, any questions at all, folks, dealing with the interquartile range? This part right here we'll have to do on exam 1. The rest of it is exam 2 material. Okay, so that's the use of this nice formula here. It's always good to emphasize it is just a rule of thumb. Suppose we did find an outlier. First thing people are going to do is start looking at it really closely, see how it fits in, see if it really feels like an outlier for talking about left skew. Maybe it fits the left skew pattern well. It's not a big bother. In other words, if you use this rule of thumb, and don't think about it as a rule of thumb, it can give you results that look just totally contradictory. Let me show you an example of that. Let's go back to chapter 2 for just a moment. And I think I want the one in shape, quantitative data. If I use the 1.5 IQR rule of thumb on these data, you will find outliers. You'll find a bunch of them. There'll be outliers here. This is -3 standard deviations away from the mean of 0, which is quite unusual. You'll find outliers here, 3 standard deviations away from the mean, but still, for a pattern of symmetric data like this, you would still say no outliers, and that's really the right conclusion. The sample size just happened to be gigantic, and when we take really, really large samples, sometimes you get extreme observations. These extreme observations fit the pattern of unimodal symmetric data like this. So that rule of thumb, if we applied it here, you're going to see things that didn't fit with what we said visually from the beginning. So it's a thing to just keep in mind. We really mean it when we say rule of thumb. You have to take a lot of other things into consideration. What does the data look like on the histogram? How big is the sample size? And those other kinds of thoughts as well. For smaller samples, if there was an outlier here, it's going to match up with what we really see on paper and what the rule of thumb is going to say. It usually does a pretty good job on a small sample like size 16. But let's practice it again. Any last questions or comments before we try the next problem? Okay, the next problem is kind of a silly context. I forgot about this one. What we're doing here is presenting a new display of data. This one is going to be called the box plot. Some people have possibly studied box plots before. Have people seen them? Awesome, several people in the class. That's great to hear. Box plots are a nice way to visualize data. Essentially, all the box plot is doing is it visually shows the 5-number summary and outliers as well. We'll plot the outliers in a special way. So it's a way to represent your 5-number summary, show if there's outliers in the data set. But when we do example 2, you might think to yourself, I like the histogram better. It seems to give me more information than a box plot because a histogram is telling me a whole bunch of regions where data is accumulating. The box plot feels like a blunt tool out of nowhere. So maybe before we even do example two, let me show you where example two shines. It's not in this context with one quantitative variable. A box plot is great for these kinds of data, where you have a quantitative variable and another variable that's going to be treated as categorical. Age is thought of as categorical in this data set. We're classifying people according to the age that they are. And this is their lung strength. This is a whole bunch of box plots at once. And it's a way to take something like this. This is their lung strength in a histogram. Sure, it looked like it gave us a lot of information, but there are more variables in this data. We want to separate out how the other variables interact with lung strength, FEV. We need more tools, and this is where box plots are terrific, showing you way more things you could ever have seen in the histogram. First, before we look at this picture, it's pretty busy. It's hard on my eyes, even though I know what these box plots are. We want to study a box plot first in isolation, just one of these at a time. Then we'll see what's going on in this bigger picture here. I'll look at it again. Two box plots together is something you'll see in the homework set as well. And you might see some larger amounts like this in the homework set as well. Mostly there'll be conceptual questions you're going to be asked. And for some questions, you'll be asked to actually just construct your own. So let's give this a try. To construct a box plot, here is our step one. Compute the 5 number summary. And maybe there's a step before that even. If we're going to make a box plot and there's a part B that says, describe what you see in the box plot using the context, before we launch into step one, let's absorb that context. Let's see what's going on. So this is real data, and this is something that happens every year, it turns out, unless they stopped, which would be sad in a way. The data I have is from 2013. And this is from the Cornell Lab of Ornithology. I had to look this up the first time I saw this. This is the study of bird species. So the Cornell Lab of Ornithology, they really do this. They hold an annual Christmas bird count. And you can find this at birdsource.net.org. So if you're really curious about this, you could check out more about this party. In this annual Christmas party, here's what they do. Bird watchers at various locations around the country, so all over USA, see how many different species of birds they can spot. So imagine you have a lot of bird biologists. They're probably taking lots of eggnog, some of it probably with vodka, who knows? And they're just hanging around. It's like a department party, and they're looking at the sky, trying to see how many species they can spot. They had a tough semester. I guess that's how they unwind. Here are the number of species counted from 20 sites with the most species in 2013. So this is not the entire 2013 Cornell lab party, but this is the 20 top sites. So if you look at these data, this is sorted data. The minimum is 82. I wish I had locations in the country on this. I might have to go to birdsource.org if I want to improve this data set. But they spent one day and all of the ornithologists found 82 bird species on their Christmas party. I don't know if they hold this like on December 20 or something, or like Christmas Eve, who knows? This one's kind of suspect to me. One location reported 184 bird species. Maybe that's an outlier. We'll be able to see that in our box plot when we go to construct it. We'll use the rule of thumb to detect it. And if it's an outlier by our rule of thumb, maybe they should take another look at the data. Maybe they took photographs and said, this is the species we found. Sometimes outliers are just mistakes. Maybe they got a little too wild on this Christmas party. Maybe there was too much alcohol and everyone thought they found a different species, but there's like 50 photos of the same species after they sobered up and looked at it again. So sometimes you have to go back when you find an outlier, see what's going on with the original data, and sometimes you're just fixing mistakes. Other times it's real. Maybe this one party was just in like the best spot in USA with all sorts of bird species, and that's what really happened. So any way we look at it, putting data back into the calculator. So let's give this a try. First thing you do is hit the stat key, go to edit right away. It's never harm in deleting these one at a time, like we mentioned before. But I like to plug this shortcut because it can be tedious to do that. Hit up arrow, clear, and enter. If L1 is gone when you're doing this on exam one, I can help you with that. Don't hesitate to ask. I can help you bring that back. Any weird other issues on your calculator, if I can't solve, I'll have a loaner calculator that I can lend to you. Okay, I'll get quiet as I go. I'm going to do these column wise. Okay, I think I've got my data imported. Anyone need any additional time? Okay, you're all getting good at this data entry stuff. It's a solemn task, but it's the heart of statistics, really. We have nothing without the data. Hit stat again, right arrow, spam the enter key. It becomes a mantra after a while. It's going to turn into muscle memory. Practice this some more on the quiz 3, the sample exam exercises, and you'll be in great shape for exam 1. This is the major operation in our calculator. Then find number summary, go down here, and we grab these data here. So it goes from min of 82 species. I'll write this unit as bird species, but just once. Just a reminder to me of what the context is. Quartile 1, 97.5 species. That always seems weird because you can't have a decimal amount of bird species. But all this is trying to do is split the lower 25% of the data, the upper 75% of the data. When you have 20 observations, sometimes you get decimal answers like this. Then for median, this is 112. Quartile 3, 132. And max is 184. So aside of putting down the min and the max, this is stuff you'll have to do on exam 1. Then after we have the 5-number summary, step 2 is we need the interquartile range right away, because we're going to, in order to get a nice plot, first detect the outliers. It's part of our box plot. If we scroll down just to take a peek, see all those little circles that are floating above this little bar? Those are the outliers in the data set, and that's what we want to include in our plot. This segment is going to be the maximum. That's quartile 3. In the middle of the box is the median. Lower edge of this box is quartile 1, and that's the minimum. So that's how the 5-number summary comes into being when we go to write out this box plot. But to really get ours, we're detecting outliers first. So we need the IQR, which is quartile 3 minus quartile 1. Let's color code that just as before. So this will turn into 132 minus 97.5 Forgot to color code that. Let's just hit it with the highlighter. So interquartile range is going to come out to 34.5 bird species. This alone right here is another computation that we have to do on our exam one. Any questions on doing that part there? Okay, well, in the interest of the time we have, we can finish off the IQR rule of thumb. I think it's going to be racing through the time that we've got left, which is about 4 minutes and some change. It's rough to start a problem and just leave it off, but I felt like this is a good thing for us to do, the min, the quartile, medium, and quartile 3 IQR, just for the sake of reviewing exam one content. When we come back after exam one, we'll pick it up from right here. We'll remind ourselves what the context is, finish out this problem. But any last questions whatsoever, folks, about what we did today or anything otherwise? Okay, have a great weekend, folks. Just another quick set of reminders. Good order of operations here is first write out your page of notes, finish quiz 2. If you have the time, finish quiz 3, email it to me. I'll send back your feedback to your ISU email. So watch out for your ISU email over the weekend. Then I would say finish off my lab statistics is a good way to go. And start looking into these other sample exams to review material. You might want to focus on one section over the other, so cherry pick. Whatever section seems the most confusing is probably a good one to start in. And don't hesitate to email if you have questions. I'll be happy to help out. Thank you. Have a great weekend, folks. Try not to work too hard. Questions?
Yeah.
Mhm.
Is labeled as like chapter 1, chapter 2, or is it just?
I don't necessarily label where the chapters come from, but I am putting it in direct order though. So I'm not really mixing up the problems too much. Yeah. Thank you.
You're welcome.
Thank you.
Yep. Have a good one.
Was 2.
Awesome. Thank you.
And then I do have that issue with the L thing.
Oh, gotcha.
I've just been using L3 and made it work, but
So
show me how to fix it.
yeah, I'd be very happy to. First thing you want to do is go back to stat. And you want to hit this operation here. So this is kind of like the reset button. So hit enter on that, and then just hit enter again when it's on your screen, and it gives you a mysterious Doug.
Mhm.
Hey, Artemis. I think he's Artemis.
Artist, yeah.
Artist, gotcha.
I'm surprised you remembered it.
Sort of. So once it says that, you can go back to the stat, hit enter, and you'll see that it brought back your L1, hopefully.
Yep.
Awesome. Another thing you might want to do right away, though, is go back to calculate, hit enter. You probably have L3 here, right?
Yeah, I changed it to L3.
Yeah, so you're good on changing that back to L1 there?
Yeah.
Okay, gotcha.
So where is it that I did that got rid of L1?
Oh, it's kind of weird, and I don't know why this happens, but you can just literally go up here. You usually want to hit clear, but sometimes your gut instinct is just to hit delete,
Okay.
and it just disappears it
The
from you.
column.
Yeah.
Okay.
It's not really gone, it's just not displaying. It's still storing your information. It's weird.
So if I move over to L3 and then push clear,
Yeah,
or
and
how would I
then
get rid of all of that?
hit the clear button like you did, and then enter. Then it just wipes it out in one shot.
Okay.
He's having a good time.
Okay, thank you.
Yep, have a good one.
I'm trying to pull up, I would route my place at my house. Can I email you a picture of it?
Yeah, that'd be just fine,
Okay.
absolutely.
And then I had a question on the graph.
Mhm.
Does it have 2 peaks or is it just normal? Cause I.
Oh, let me look at it with
this
you.
side. Perfect.
I think this one was kind of tricky, if I recall correctly, yeah.
I'm gonna bring it in to ask you.
I would call this unimodal. So whenever they're at the same height, right next to each other like this would still be unimodal.
Right.
It's only if we
What
have
about
like
that?
this would be
What
just
is, like,
considered,
Is that just like,
yeah, it's like one main hump, and then out here would be just the outlier.
okay.
So this
yeah.
data would be skewed right because of that one.
Okay.
But still, we think of it as one main peak where it's concentrating the data.
Okay, and then that is the outlier.
Yeah, we'd call this one an outlier. In fact, I think our rule of thumb we just did would consider that an outlier
'Cause
too.
it's like two spaces.
Yeah, if it was here, it's borderline. You could still call it an outlier and that'd be just fine.
Okay, perfect. That's all the questions I had. Okay,
Sounds
I'll
good.
get it out to you tonight.
Sounds great. Thank you.
Okay, thank you.